Okay, we've partially completed our step coating test. We've done our initial base coating with a 2-1 coat, 2-2, 2-3. Now I've dried the screen, I've inverted it 90 degrees, and I'm going to apply the face coats. Face coats, or another term might be leveling coats, and I'm going to use the sharp edge of the trough this time to do the leveling. I'm going to apply a 3-step coating process similar to what I did with the base coats. And notice I'm going to overlap all 3 coatings so that I can take a measurement. So I coat one all the way up, 2/3 of the way down, apply a second face coat, you need to be somewhat careful in doing the face coats. When I'm putting wet emulsion on to dry and I place the trough onto the emulsion, it tends to want to re-wet the dry emulsion and it begins to stick somewhat. So I am using pretty good firm pressure when I begin that coating. So now I have on one screen a 2-1 coating plus 1 face coat, 2 face coats, and 3 face coats. I have a 2-2 coating plus 1 face coat plus 2 plus 3, and a 2-3 coating plus 1 plus 2 plus 3. When we dry this, we'll take measurements again of the thickness and the smoothness. I want to review what we've accomplished here with the step coating test. We've taken just one screen, coated it with various coating techniques. The base coating, which is your initial wet-on-wet coating, was done with a 2-1, 2-2, and 2-3 coating technique. We dried the screen, came back and applied face coats with the sharp edge trough this time and crossed the 3-step coating and did another 3-step coating with 1, 2, and 3 face coats. So all on one screen I have 9 independent thickness and smoothness variables, and we've measured all of them, and we'd like to illustrate that with each additional face coat, notice how we get smoother and smoother on the RZ value, but very minimal stencil thickness gain. Without any face coats, we had 5 microns of EOM, or emulsion over mesh. With 3 additional face coats, we only increased it by 1 micron, but we dropped the smoothness, the RZ value, from 8.7 microns to 5.6 microns. Now, if we're coating mesh for UV inks, printing for UV inks, we would want to keep our stencil thickness between 3 and 6 microns, so we can eliminate all of these measurements here because they are ranging too high. Our stencil thickness is 10 and 18, so we can eliminate this if we're printing UV inks. If I'm printing solvent-based inks, I would keep these in the running now because I can work with about 20 to 25% emulsion over mesh, and the mesh thickness was 42, and if I'm working with 20%, that's 8-9 microns, so I would be okay with these coatings here. But let's assume we're printing with UV inks. So I am going to have to narrow my target thickness to this range right here, which is ranging between 5 and 6 microns of emulsion over mesh.